As a scientist, I'm looking for the most intense beam and the smallest spot at the sample, or most optimized for the sample.
The Metaljet is really an interesting technology. Of course, what is amazing to everybody is that you literally can get an X-ray beam out of a liquid gallium target.
The current in-house sources have been either stationary metal target sources or rotating anode sources specifically for structural biology.
With rotating anode generators, you're always worrying about melting the target. With the liquid gallium, it's already liquid.
By using this high-velocity jet of liquid gallium, we're able to provide a fresh surface of gallium at the source at all times.
The big advantage of the user is a much more high-performance system. We're concentrating the X-rays to a smaller area around the crystal, giving a much more high brilliance. This gives you the maximum amount of diffracted X-rays, but also limits the amount of background scatter you get. This is a virtual fly-through of the Metaljet system showing a schematic of the inside. And the whole process starts by an electron beam that is generated by a high-brilliance, long-lifetime lithium hexaboride cathode. The beam is focused to a very small spot, providing a very high brilliance. This electron beam travels down the path until it reaches the liquid gallium jet. Gallium has a corresponding X-ray energy of 9.24 keV, which corresponds to a wavelength of about 1.34 angstroms. Just slightly shorter than the wavelength for copper, 1.54, which is typically used for structural biology. The X-rays travel down the path until it finds the gallium mirror, which is optimized for the gallium radiation, producing a very high brightness, high performance X-ray beam.
Gallium is interesting because it's 1.34 angstroms, so it's somewhat shorter than the copper of 1.54, and that means that you get more data in a single setting of the detector.
Because of the brilliance of the Metaljet source, I'm able to collect absolute configuration data on the smallest samples in a very short period of time.
The liquid gallium Metaljet source is a perfect solution for those really cutting-edge research problems.
The Metaljet is not only the best performing X-ray source, but also the best as far as maintenance and running costs.
It requires a lot lower power and only single-phase power.
There are fewer moving parts, there are fewer things to replace, and it's also air-cooled, and so you have a system that's very user-friendly as far as maintenance goes.
It gives us the opportunity to have a much brighter home lab source. It really runs rings around the rotating anode generators.
Rotating anode sources have served us well over the last 30 or 40 years, but the performance enhancements that you'll have with rotating anodes are pretty small at this point, and we're looking for something that sort of goes past that barrier, and the Metaljet can provide that.
My experiences with the Metaljet have just been fantastic. The ability to diffract off such small samples has been just stunning for me.
It's already as good as anything else out there, and it's got a potential for being, 1 to 2 orders of magnitude above anything else we have right now. It could very well be the future of X-ray production for structural biology.
We believe that it's only the beginning of a wonderful line of products based on the liquid Metaljet technology.